So welcome, my name is Kalyesubula, currently pursuing a bachelor's degree in computer science, and I'd like to present to you the visualization done in D3. But before I get to the dashboard, I'll just show you a high-level picture of what actually I went through to come up with a visualization. So this is the introduction. We'll look into the visualization tools, data preparation, the actual visualization, conclusion, and recommendation. So, looking at the water quality data set that was mined from mainly um, the processes that I followed under visualization included installing XAMPP, installing Laravel, it's just a PHP framework, creating a database that was based on MySQL, and then creating a database schema. So away from that, I had to step into data pre-processing because the data set was not consistent. There are some rows that had different namings. There are some rows that like blank, they were blank. So I had to go through a process of data preparation. So in that sense, we are trying to look at data completeness, checking for any uniformity if it does exist for all the fields, for all the sheets. Then had to create a migration script to see how the data is imported into the D3 for visualization. Then I had to test and refine the migration script on the water quality data set. So again, I looked into the loading process. Since D3 is just a JavaScript library, I had to import it using the content distribution network. So then from there to head straight to the visualization, and the language I used was a PHP, a JavaScript, and then these other languages that help me to do the styling. Okay, so from a high level end, this is a donut graph. So with this donut graph, basically you're looking at how each parameter looks like from a visualization perspective, and I had to create filters whereby a user just checks the filter of their interest and then they activate it by click on the filter button, then the values keep on changing and the legend is displayed on the right. So basically this is a district picture starting from that perspective. So looking into another visualization that was created, this is a circular bar chart. This was quite interesting in the sense that if you have different water points, you want to visualize a particular parameter and how it is distributed across the water points, then this is something interesting that one would really run into. So it's not only specific to parameters, but in the filter, it's able to pull all the parameters that were used in collecting the data about water quality. So bit pH, bit total alkalinity or total hardness or electrical conductivity. So the user just navigates in there and then is able to, see the picture, how that variable spreads through for all the different water points. So, this is another interesting visualization. It entails a bit of padding, zooming, and here and there, and it's called a circle path. So basically, in here, I first looked at three parameters: pH turbidity and electrical conductivity, given the fact that those are the key, among the top variables that determine the water quality. And what the user basically does is that as they click on the circular representation, it's able to dig down deeper into the representation of those actual variables. So with this is that if you look at the bigger picture, you see that these circles are dependent on the magnitude or the absolute values for those parameters. So lastly, this is I scaled it further to other variables, the total alkalinity and total hardness, and this is still the same picture that I used. So well, I'll stop at that. I would like to head straight to the to the to the dashboard to demonstrate the actual visualizations, how one clicks and then they're able to visualize the actual data. But again, in my slides, I'll include a link to the GitHub account to see the actual code. So let me stop sharing so that I can head straight to the dashboard. Okay, so let me share. Okay, well, so this is locally hosted, as you can see. The IP is at 127.0.0.0.0.1. It's a local host hosted on XAMPP. So at a glance, what we see starting off with is that we are looking at various parameters for water quality, and this is a district picture. So basically what the graph does is that the user is able to get a whole picture of how that particular parameter is evenly distributed. And how do they do that? Is that you click on the filter, as you can see, and then down here you see they're able to select, let me say pH. Let me select pH and see. So after selecting pH, then I click. So you can see that pH values are distributed that way, but if you look at all the values, they are really lying in a range of 6 to 4. Sorry, 7 to 4. So that is a close distribution. So let me pick out another variable. Let me say electrical conductivity. Click filter. So this is another representation. You see that Bugweli has that value, Luka district has that value, Movende and Wakiso. So this is a top picture of how different districts are performing in terms of the water quality. In this case, a particular parameter that was considered. So we are using an average case. So let's head to another visualization. And with this visualization, of course, I try to apply some bit of filters whereby one just clicks on the filter and then it's able to, do the kinds of plotting. So let's start off with any variable. Let me say pH. Let me select pH. It's down here and I click filter. So when I scroll down, you see that almost all the water points had a pH variable. But okay, since the screen is kind of small, but you can absolutely see how the pH values are, are spread across the different water points. Let me select a clear one. Let me just select any. Let me just select any, like electrical conductivity. So when I select electrical conductivity, you see that Our Lady Secondary School had a bigger value for electrical conductivity. And then you see that there is another water point called Nankonge borehole. You see that its value was lower. So why this graph? Basically, it helps you to draw conclusions. And if you look at all the water points, and then specifically for electrical conductivity, you see that it's basically Our Lady with the highest value. So you're able to make the deductions. So let's look at another graph. That's about the distribution of pH stability and electrical conductivity, given the fact that these three variables are key in determining water quality. And there's some bit of padding and zooming applied here. So at a glance, you're able to see the districts, Luka, Wakiso, and Bigweri, Movende, and then these other ones. So the circles are dependent on the magnitude of the representation in data set. So let's just pick out just one district. Let me say Luka in this case. So you see that the moment it's clicked on, it's zoomed out, and then within that you're able to see the electrical conductivity value, you're able to see the pH value, you're also able to see the turbidity value. So I can also zoom out by clicking on the extreme edge. So let me select another one called Buyukwe. Buyukwe, where is Buyukwe? It's here adjacent to Mubende. So when I click on Buyuke, you see that it also shows me the electrical conductivity and also the turbidity and the pH value. So this is the whole essence that D3 creates. You're able to do the zooming and the padding to see how the data is evenly distributed. So let's look at another graph. Probably it's the last one. So this other one looks at total alkalinity and total hardness. And with this is that you're also able to see the same representation. So meaning that if I have maybe a range or a scale, then I would definitely evenly represent the variables. So clicking on, let me say, L'amour, in this case, if I click on L'amour, you see that I'm able to see the total alkalinity value and the total hardness. So well, D3 has really proven to be an interesting library to use in terms of a visualization of data, and this is some of the framework that should be recommended for any data-driven organization. Let me give an example of Ministry of Health. So we work with a couple of data sets, but again, if you look at the visuals that are created, they are not really up to that standard. So this is some of the recommended library that I will really take on to see that it's really implemented in the health information systems at the ministry. And I'd like to thank you, Doctor, for really pushing us and showing us light where visualization is taking path. And it's a pleasure. Thank you.